Good afternoon, everyone. We are Team Pi, and today we'll be introducing our analytic solution called SpaceCzar. Before going into our prototype demo, let me first elaborate our motivation behind our solution. We have identified some problems that students like ourselves typically face when we are looking for spaces around campus. The first problem is that students have an imperfect knowledge of study spots around campus. Students are unaware of all the available spaces catered for studying and holding group discussions. And sometimes, students just want to find the nearest space, but are unable to do so because of the imperfect knowledge. As a result, there is a demand for such places, but because students are not aware, some of such spaces could be left underutilized while others are being overcrowded. The second problem is that it is also very difficult to find available spaces to study, especially during exam periods like midterms and finals. Which also leads us to our third problem. Because students do not know what spaces are available or not, we end up wasting our time going around campus to search for spaces to study. This is very inefficient because time is very critical, especially during exam periods. And lastly, the current facilities booking system is also not intuitive enough. After identifying all of the above problems, we have come up with our application in hopes of resolving those problems. Our application is called SpaceCzar and is your go-to stop for information about spaces and places in NUS. Now, let me introduce the main features of our application. Firstly is the real-time mode, whereby students can immediately look for a spot using our solution. It will show a heat map of current available spaces around campus. And we will also recommend spaces to the user based on its vacancy rate, proximity to its current location, and the type of space, for example, study rooms. So now users can save time by not having to worry about walking around campus in search of a place, as we will do the searching for the nearest available spot for them. Secondly is the forecast mode, for students to plan maybe a study date or even a group discussion in advance. With a date and type of space in mind, we will help predict and analyze the estimated vacancy of spaces and also crowd distribution across location or time. Once a specific place is chosen, recommended bus routes and general tips are also shown. The third feature is the booking system. It will show a list of available spaces around campus upon choosing a type of venue or time. The interface will be efficient, intuitive, and offer convenient booking of spaces. Our last feature would be the personal profile, whereby users will log in with their NUS Net ID, and they can easily keep track of their favorite campus spaces, which will be analytics done based on their usage on our app. They can also view and manage current bookings easily on their profile. So now I'll begin the demo of our application. So this will be the login screen, and the user just needs to log in with his NUS Net ID and password. So after the user logs in, they'll be brought to this page. This is the home page and is also their profile page. So on the left, the user can keep track of their usual hangouts, which will be analytics done based on their usage of our application, such as past bookings that they have made. And the user can view and manage their current bookings, which haven't expired yet, through the My Bookings pane here, and it will show the details of each of their booking. So for example, I want to cancel a booking, I just need to click this button and the booking can be cancelled very easily. So on the right will be our three main features of the application: the real-time mode, forecast mode, and also the bookings. So firstly, I'll go through the real-time mode. So what the real-time mode does is it will help to recommend spaces to the user based on the space's vacancy rate, the proximity to the user's current location, and also the type of venue. So the user just needs to select a current location and the type of venue, which will be study rooms that can be tapped in using their metric card, or discussion rooms which can be booked. So for example, I want to look for study rooms and I'm at arts. So the app will recommend a place that will be based on the closest proximity and the highest vacancy rate. So on the left would be the interactive map, which the user can easily filter by region or by status. And the markers are actually color-coded according to the status, which will be red, yellow, or green. And if you click on the marker, it will show the name of the place and the number of seats available, and also the operating hours. So now I will go through the bookings feature. So basically the bookings feature allow the user to book a discussion room based on the date and time that they want. So if I choose a date and the earliest timing would be 9 a.m. So if I want it at 11, so it will show me a list of places with discussion rooms available at the date and time that I want. So for example, I want to book at Central Library. So this will be the screen that it will be shown if the booking has been successful.
Now we will take a look at the forecast feature. In the forecast feature, users can only choose the study rooms as the type of venue because for discussion rooms, they will be able to see if there are available rooms through the booking feature. So, first users will choose the date and a type of venue. And they can choose to forecast based on location or time. We will choose to forecast based on location. In this page, the list of these locations will be shown and users will select their location. Let's take a look at Central Library. And in this page, the crowd distribution at Central Library throughout the day will be shown.
Having gone over a demonstration of our app and explored some of the feedback given by our prototype survey respondents, let us explore the technologies that are being used to facilitate the functionalities provided by the app. To support our app, we are using three main technologies. To store details about locations, Firebase is acting as our backend real time database, which allows us to support our functions such as illustrating real time occupancy rates. Subsequently, we are using Code Sandbox, which is our JavaScript editor. That is acting as the bridge between the real time database hosted on Firebase and our GUI. We are using this as it provides us with the visualization of how our GUI will change depending on changes made to our code. To allow for easy real time visualization in the form of feature maps, which works well in conjunction with Firebase, we are using Google apps such as Awesome Tables. So, having understood the technologies, let's look at some of the potential enhancements that could make our app better. So, at the moment, the basic structure is present. However, the app is not in its optimal state yet due to the usage of mockup data in our application. In addition, our application is also not fully functioning because it would require extensive mockup data, in which it would be difficult given the time period of this project. Hence, the use of some features are restricted to a small date range. This is applicable particularly for the forecast feature. Going forward, if the web page is fed with actual data, this can allow for better forecasting methods after exploratory data analysis prior to deciding on the best forecasting model. In addition, video analytics and IP address data could help increase the accuracy of data in real time. So, now let's take a look at the status of implementation. As we can see, we have all our features done, but as mentioned earlier, our biggest concern is the accuracy of our data, which will be improved perhaps through better data collection. So, that brings us to the end of our presentation, and we hope that this app can help improve the on campus experience for everyone in NUS. Thank you.